Module 6. Implementing a weather station in Algobuilder. In this module, we will use Algobuilder from MEMS Studio to create a weather station application. We will read temperature, humidity, and pressure data from environmental sensors on the IKS4A1 board. We will use Algobuilder to convert data read from the sensors to different units. Lastly, we will display the data in a custom window within MEMS Studio. Algobuilder is a graphical tool which allows you to quickly create custom STM32 applications without writing any code. Our application will read temperature and humidity data from the SAT40A-D1B sensor on the IKS4A1 board. The SAT40A-D1B is a high-accuracy, ultra-low power relative humidity and temperature sensor from Sensirion, part of the ST Partner Program. It features a relative humidity accuracy of 1.8% and a temperature accuracy of 0.2 degrees Celsius. For pressure data, we'll be using the LPS22DF sensor. The LPS22DF is a low-power, high-precision MEMS nanopressure sensor with an operating pressure range of 260 to 1260 hectopascals and output data rates of up to 200 Hz. Let's start. If it's not already running, open MEMS Studio. Then click on Algobuilder on the left. The Algobuilder tool contains several windows. Along the top is a menu. By hovering over each button, you can see a description of the action associated with it. You can use these buttons to create, save, or load a design. There are also buttons to edit the design, align blocks, and generate and build code once the design is complete. We will make use of many of these features in the next few minutes. Along the left, we have the library window. This is used to search for and select the blocks we will use to create our application. We can expand each category to see which blocks are available. The Subdesigns window allows us to use a hierarchy of designs in our project. We will not be using subdesigns in this lab, but feel free to explore this feature once you have completed the workshop. In the middle, we have the main design window where we will create our application. Below it is a console window, which will display messages as we perform actions on our design. Finally, on the right, we have a description window and a properties window. These provide us with information about the currently highlighted block and allow us to configure its properties. Let's start designing our application. Click on New Design. The first thing we need to do is specify a location for our design and configure the tools and hardware we will use in our project. Let's select the location for our project. Click on the Browse button and navigate to c://mems_studio-workshop/module6/Algobuilder. Then click Select Folder. Next, for the Toolchain IDE, make sure STM32 Cube IDE is selected. Finally, we need to specify the hardware we will be using in this lab. Expand the target drop-down list. Scroll down and select Nucleo F401RE plus X Nucleo IKS4A1 LSM6DSV16X. Note that there are two listings for the Nucleo F401RE plus X Nucleo IKS4A1 board combination. Each entry enables the use of one of the two different IMUs present on the IKS4A1 board. Although this module does not make use of the IMU, please select the entry enabling the LSM6DSV16X for this workshop. Once the target is selected, we can see which sensors are available to use. In this module, we'll use the SAT40A-D1B for temperature and humidity data and the LPS22DF for pressure data. Next, click OK to confirm the firmware settings. In the main window, you may have noticed that there is already a block called Sensor Hub in the design. This block represents all the sensors present on the board. Click on the Sensor Hub block to view the properties associated with it. In the Properties window, we can adjust some of the parameters of the sensors, such as the data rate and full scale, to match what we need for our application. Make sure that the data rate control is set to timer. Note that the data rate is set at 100 samples per second. Although this is very high for a weather station, let's leave it as it is for this module. This will allow us to visualize a lot of data in a short period of time. You can experiment by modifying this setting once you have completed the workshop. We will not be using the accelerometer or gyroscope in this module, so we can leave their settings as they are. To use a particular sensor's data, we need to retrieve the data we want to use from the sensor hub. We do this by placing a retrieve block in the design and connecting it to the sensor hub. For our weather station, we want to retrieve humidity, temperature, and pressure data from the sensor hub. Let's start with temperature. In the library window, scroll down to Sensor Hub and expand it. We see several types of environmental, motion, and other sensors listed. These blocks can be used to retrieve data from the sensor hub. Find the temperature block and click on it. In the description window, we can see information about the block, including its function, inputs, and outputs. Drag and drop the temperature block to the right of the sensor hub. We have now added a block to our design. Let's repeat the process for humidity and pressure. Click on humidity and drag and drop it below the temperature block we just added. Lastly, find pressure and place it beneath the humidity block. Next, we need to connect the 3 blocks we added to the sensor hub. Click on the output pin on the sensor hub and drag the connection to the input pin on the temperature block, then release the mouse button. You should see a line connecting the sensor hub to the temperature block. Repeat the process to connect the humidity and pressure blocks to the sensor hub. You should now have the sensor hub connected to each of the temperature, humidity, and pressure blocks. Our application is retrieving temperature, humidity, and pressure data from the sensors. Next, we want to display the data on the screen. For each sensor, let's display the current reading, as well as a graph to show readings over time. Scroll up and find the display category in the library window. Expand it and select Graph. Then drag it onto the design window, placing it to the right of the humidity block. The graph block allows plotting several values in the same graph. By default, it is configured to plot 3 values. We'll need to configure it to match the output of the humidity block. Click on the humidity block to select it. In the Properties window, we can see that the output is a single floating point number representing the relative humidity as a percentage. We need to change the graph block's properties so that it expects a single input value. Click on the graph block. In the configuration window, set the number of curves to 1 and hit Enter. Now the graph block expects a single input value. We can now configure the rest of the graph's properties. In the name box, type humidity graph. For the waveform 1 name, type relative humidity. Lastly, set the unit name to %. Next, let's add a value block to show the current humidity reading. In the library window, select Value from the display category and drag and drop it to the right of the humidity block. As we did for the graph block, we'll need to configure the value block's properties to match the output of the humidity block. Click on the value block. In the Properties window, set number of values to 1 and hit Enter. In the name field, type humidity value. In the Value 1 name field, type relative humidity. Finally, for the unit, enter %. Now that we have configured the two display blocks, we can connect them to the humidity block. Click on the humidity block's output pin and drag the connector to the input pin of the graph block. Repeat the process to connect the humidity block to the value block. This completes the part of the application related to humidity. Before we move on to temperature and pressure, let's quickly review what we have done so far. The humidity block retrieves humidity data from the sensor and outputs it as a single floating point number representing the relative humidity. This data is then sent to the graph block to be plotted, as well as to the value block to be displayed as a numeric value. Let's now look at temperature. Click on the temperature block. In the Properties window, we can see that it has an input that must be connected to the sensor hub output. We can also see that the output is a single floating point number representing the temperature in degrees Celsius. Suppose we want to display the temperature in degrees Fahrenheit. Algobuilder provides a useful conversion block, allowing us to do the conversion. Let's add it to our design. In the Library window, scroll down until you find the temperature category and expand it. Here you will find two converters. One converts Fahrenheit to Celsius and the other Celsius to Fahrenheit. Click on the Celsius to Fahrenheit converter block. In the description window, we see that it takes a floating point number representing the temperature in degrees Celsius as input, converts the value to Fahrenheit, and then outputs that value as a floating point number. This is exactly what we need. Let's add the block to our design. Drag and drop the Celsius to Fahrenheit converter into the main design window to the right of the temperature block. Now let's connect it to the temperature block. Drag a connector from the temperature block output pin and drop it onto the converter input pin. Let's now add graph and value blocks to the design to display temperature data as we did for humidity. In the Library window, scroll to the display category. Add a graph block and a value block to the design, placing them to the right of the Celsius to Fahrenheit converter block. Let's now configure the graph block to match the converter output. Select the graph block. In the Properties window, change the number of curves to 1 and hit Enter. Set the name to Temperature Graph. Also set the Waveform 1 name to Temperature. Finally, set the unit name to degrees Fahrenheit. Leave the other parameters as they are. Next, select the value block. Change the number of values to 1 and hit Enter. Then set the name to temperature value and the value 1 name to temperature. Lastly, set the unit 1 name to degrees Fahrenheit. Now connect the two display blocks to the output of the temperature conversion block. The final part of our application is to display atmospheric pressure. We'd like to display the values in inches of mercury. Select the pressure block. The pressure block output data is in hectopascals. Similarly to what we had to do with the temperature data, we need to convert the readings from hectopascals to inches of mercury. In this case, however, Algobuilder does not provide a converter block for us, so we will need to implement our own conversion. Let's look at the formula used to convert hectopascals to inches of mercury. Pressure in inches of mercury equals 0.02953 times the pressure in hectopascals. Algobuilder provides math and constant blocks, which will allow us to implement this function quite easily. Scroll to the Math category in the Library window and expand it. Find the Multiply block and drag and drop it onto the design to the right of the pressure block. Highlight the Multiply block in the design window. By default, it takes two floats as input, multiplies them, and then outputs the result as a float. In our case, one of the inputs will be the pressure in hectopascals, while the other will be a constant of type float. Let's add the constant. In the Library window, scroll to the Constants category and expand it. Drag and drop a constant float block onto the design and place it underneath the pressure block. Select the constant block in the design window. In the Properties window, set the value to 0.02953. We can now connect the pressure block output to one of the multiplier inputs. Next, connect the constant float output to the other input pin of the multiplier. We have now implemented the hectopascals to inches of mercury conversion. Lastly, let's add a graph block and a value display block to our design as we did for humidity and temperature. Scroll to the Display category in the Library window and expand it. Drag and drop the graph and value blocks onto the main design window and place them to the right of the multiplier. As we did with humidity and temperature, configure the graph block to plot a single curve. Now set the name to Atmospheric Pressure Graph. For the waveform 1 name, type Atmospheric Pressure. Set the unit name to inches of mercury. Leave all other parameters as is. Next, select the value block and set the number of values to 1 and hit Enter. Set the name to Atmospheric Pressure Value and the value 1 name to Atmospheric Pressure. Lastly, set the unit 1 name to inches of mercury. Let's connect the output of the multiplier to the input pins of the value and graph blocks. We have completed the design of our application. Let's save the design. Click on the Save Design icon. If asked to provide a name and location, navigate to c:/mems_studio-workshop/module6/Algobuilder. For the project file name, type Weather Station. Then press the Save button. Next, we need to generate the C code for our application. Press the Generate C Code button. At this point, you may get a notification indicating that the project directory was not initialized. Go ahead and press the Overwrite button to initialize the folder. You will get a notification in the console window when code generation has finished. We are now ready to build our application. Press the Build button. Algobuilder will build the application using the tool chain we configured at the start of the module, STM32Cube IDE. Information about the build process is displayed in the console window. It may take a few minutes for the build to complete. Once complete, you will get a notification in the console window. Feel free to pause this video until your build is complete. We can now flash our application to the board. If not already connected, connect the board to the PC using the USB cable, then wait a few seconds for the PC to detect the board. Now press the Program Target button. Algobuilder will launch the STM32Q programmer in the background and start programming the board. Once programming is complete, you will see a message in the console window saying "Download verified successfully." We are now ready to run our application and view the environmental sensor data. Click on the Connect icon on the left side of the screen. Make sure the communication type is set to serial. The COM port should have been automatically selected by MEMS Studio. Click the Connect button to connect to the board. Once connection to the board is established, the Algobuilder evaluation window will automatically be displayed. Press the play icon in the top left corner to start streaming sensor data to the PC. The options under Algobuilder evaluation will allow you to display the data being read from the sensors. You can view the temperature, humidity, and pressure graphs, as well as the current sensor readings by pressing the corresponding buttons. If you click all line charts, you will see all three graphs displayed side by side. Data table and data monitor allow you to observe all values either in a table or as individual data points. Lastly, if you wish to analyze the data using third-party tools, you can log the data to a file using the Save to File option. Let's now create our own custom window showing the environmental sensor data for our weather station. Click on Custom Layout. We see a 4x4 grid. We can select one or a group of cells to hold our display widgets. Start by selecting a 2x2 set of cells using the mouse. Click on the cell in the top left of the window and then drag the mouse pointer to highlight a 2x2 set. Releasing the mouse button will show a window from which we can select the display widget to place in the highlighted cells. Choose the temperature graph. Next, repeat the process to place the humidity graph in a 2x2 section under the temperature graph. Finally, add the pressure graph in a 2x2 section to the right of the humidity graph. We now have all three graphs displayed on screen. Let's now add the temperature, humidity, and pressure value displays. Use the 4 free cells to the right of the temperature graph. Start with the temperature value. Click on the free cell in the top left and select the temperature value. This adds the current temperature reading display to the window. Now repeat the process for the humidity and pressure values using 2 of the remaining 3 cells. Our weather station is now complete. The graphs and values are being updated 100 times every second, since this is the data rate we selected in the Sensor Hub properties. You can gently blow on the board to see variations in the readings. Once you have tested your weather station application, press the Stop button in the top left to stop streaming data from the board. Also disconnect from the board. Click on the Connect icon in the left menu. Then click Disconnect. In this module, we learned how to use the Algobuilder tool to quickly build a weather station application without writing a single line of code. We configured the sensor hub and the various building blocks to meet the requirements of our application. We also learned how we can use various Algobuilder blocks to process the sensor data to suit our needs. Lastly, we created a custom layout to display the data for our application. This concludes Module 6.